Hello there, I Aishwarya Kapoor welcome you all to another episode of Science Monitor, a show that brings to you the most significant news from the world of science, technology, innovation, research, discoveries and much more. First up, the biggest science headlines this week. Nobel Prizes 2017 for Chemistry and Physics awarded for breakthrough discoveries to determine structures of molecules at great detail and the detection of gravitational waves for the first time. While the world celebrated International Day for Disaster Reduction on 13th of October, we look at the science behind earthquakes, the unpredictable disaster faced by India and indeed the world. The air quality during Diwali deteriorates every year due to burning crackers. We bring to you a report on the environmental and health problems it can cause and precautions to be taken. Scientists at IISER, Thiruvananthapuram, Kerala develop a new material to clean oil spills in oceans and rivers. Our top story this week. The Nobel Prize in Physics for 2017 was awarded to Rainer Weiss, Barry C. Barish and Kip S. Thorne for their decisive contribution to the Ligo detector and the observation of gravitational waves. While the Nobel Prize for Chemistry was awarded to Jacques Dubochet, Joachim Frank and Richard Henderson for developing cryoelectron microscopy for the high-resolution structure determination of biomolecules in solution. Science Monitor brings you this report on both the categories.
The 2017 Nobel Prize for Physics was awarded to 3 scientists for their decisive contributions to the LIGO detector that enabled the detection of gravitational waves for the first time. LIGO stands for Laser Interferometer Gravitational Wave Observatory, an instrument setup that is situated in USA. It confirmed the presence of gravitational waves almost a century after Einstein predicted that they could exist. The prize went to Rainer Weiss, a professor at the Massachusetts Institute of Technology, and Barry C. Barish and Kip S. Thorne from the California Institute of Technology in USA. Einstein predicted that any 2 colliding objects in the universe that have a mass will create a ripple in the fabric of space and time. He named these signals gravitational waves, but he could not prove their existence. This is because by the time they travel to far-off objects like the Earth, the signal becomes weak and therefore undetectable. On 14 September 2015, for the first time in human history, LIGO detected gravitational waves. These were generated from 2 massive black holes that collided 1.3 billion years ago. The signals were traveling across the Earth when LIGO could detect them with the help of a pair of L-shaped ultra-sensitive gigantic laser interferometers situated in Hanford and Livingston in Louisiana, USA. Detecting gravitational waves will help astronomers in studying the origin and expanse of the universe and demystifying the outer space for many discoveries in the future. The Nobel Prize in Chemistry this year was awarded for the discovery of a technique called Cryoelectron Microscopy. It enables scientists to determine the structure of biomolecules like proteins, DNA and RNA in vast detail. 3 scientists, Jacques Dubochet from University of Lausanne, Switzerland, Joachim Frank from Columbia University and Richard Henderson of MRC Laboratory of Molecular Biology, Cambridge, have won this prize jointly. This technique began with the finding of Joachim Frank between 1975 and 1986, when he developed a method to merge 2D images of an electron microgram to obtain 3D images and analyze them using computer software. Electron microscopy was known since 1931 and was first used to find ultrastructure of insect mouthparts, antennas, and plant and animal cell membranes. In this method, a beam of electrons is used to focus on objects. This beam of electrons hits the object and gets diffracted, which provides a way to visualize the structure of the object at higher magnification of up to 1 million times. This can be understood by an example. When a person stands in the path of light, it hits the person, gets diffracted and forms a shadow on the wall. This shadow can help to determine the shape of a person. Electron microscopy works in a similar manner but can provide images at a very high magnification. But electron microscopy was never previously used for nanoscale molecules like proteins. In 1990, Richard Henderson for the first time used an electron microscope to see the ultrastructure of protein. But this method had a fundamental problem. The protein was exposed to vacuum during electron microscopy, which dried the sample. Hence, proteins in their natural state could not be visualized by this method. A significant improvement came next when Deboucher succeeded in cooling proteins and other biomolecules using liquid nitrogen before imaging them under an electron microscope. Liquid nitrogen has a temperature of -196 degrees Celsius that freezes a sample very rapidly. Instant cooling does not alter the structure of biomolecules. The benefit of this method is that proteins and other biomolecules can be studied in real time while they are performing their functions in solution. The finding has taken science to a new era, making it easier for scientists to capture 3D live images of biomolecules, which will help to make newer discoveries in the field of biochemistry and medicine.
Every year, 13th of October is celebrated as the International Day for Disaster Reduction. The aim is to reduce the exposure of people to disasters and raise awareness about the risks faced, such as strategies for disaster prevention, mitigation and preparedness. India has faced the brunt of many earthquakes as parts of the country are in seismic zones. Science Monitor brings you a report on the causes of earthquakes and the recent technologies used to study this natural phenomenon.
India falls quite prominently on the global seismic belt that occurs from the north towards the northeast direction and collides with the Eurasian plate along the Himalayan mountain range. According to the Bureau of Indian Standards, India has 4 seismic zones: 2, 3, 4 and 5. Where Zone 5 is the most active region, a seismic zone is a region with an increased risk of seismic activity that causes an earthquake. Dividing the country into different seismic zones helps to identify high-risk areas and design strategies for mitigation. The entire northeastern region falls in Zone 5 along with the parts of Jammu and Kashmir, Himachal Pradesh, Uttaranchal, Rann of Kutch in Gujarat, part of North Bihar and Andaman and Nicobar Islands. In the last century, 5 major earthquakes with a magnitude of 7.0 have occurred in this region. Zone 4 covers remaining parts of Jammu and Kashmir and Himachal Pradesh, Union Territory of Delhi, Sikkim, northern parts of Uttar Pradesh, Bihar and West Bengal, along with smaller regions of Maharashtra near the west coast and Rajasthan. Zone 3 comprises of Kerala, Goa and Lakshadweep Islands, Punjab, Rajasthan, Madhya Pradesh, Orissa, Andhra Pradesh, Tamil Nadu and Karnataka. Zone 2 covers the remaining parts of the country. Tectonic plates are pieces of Earth's crust and uppermost mantle together referred to as the lithosphere. The plates are around 100 kilometers thick and consist of 2 principal materials, oceanic crust and continental crust. These plates move relative to each other, typically at a rate of 5 to 10 centimeters per year, and interact along with their boundaries when they converge, diverge or slip past one another. Such interactions are thought to be responsible for most of Earth's seismic and volcanic activity. The point of origin of an earthquake is called the hypocenter or the focus, while the point directly above it on the surface of the Earth is called the epicenter. Due to the strong vibrations around the point of origin, the degree of destruction is greater around the epicenter. The branch of knowledge that deals with the study of earthquakes is called seismology, and the experts who study seismic waves are called seismologists.
Tectonic earthquakes are the earthquakes which occur because of plate movement. If you look at the globe, the entire globe is made up of several plates and they are moving with respect to each other. And in that process, at some places they collide with respect to each other. One plate subducts under the other plate.
There are 3 types of seismic waves that spread in all directions from the hypocenter or the focus. They are the P, S and L waves. The P or primary waves are the first to reach the earthquake recording station as they travel 1.7 times faster than the S or shear waves, also known as secondary waves. The primary waves causes the particles of rocks to vibrate to and fro in the direction of waves. Secondary waves, on the other hand, causes the particles to oscillate at right angles to the direction of the waves. When P and S reach the surface of the Earth, they get converted into L or love waves. The most violent shocks and subsequent destructions are caused by these L waves. The instrument used to detect and record seismic waves is called a seismograph. The recorded signal appears like a graph and is called a seismogram. To measure the magnitude of the earthquake, a Richter scale is used. The point scale is arranged in such a way that each of the units on the scale is equivalent to 30 times the energy released by the previous unit. Till date, no scientific technique is available anywhere in the world that can predict the occurrence of earthquakes with reasonable degree of accuracy with regard to space, time and magnitude. But now, Indian Institute of Technology, Roorkee is planning to install a network of 100 earthquake sensors between Chamoli and Dharchula in the Kumaon region of Uttarakhand, covering a total spread of over 200 kilometers. These sensors will monitor seismic activities in the region and also help to alert the nearby communities, speeding up the evacuation process and prepare the system in the event of an earthquake.
It's time for a short break in Science Monitor, but when we come back, we take a look at the environmental and health problems caused by crackers during Diwali and the precautions taken by the government to prevent them. Keep watching Science Monitor.
The world today is talking about reactive nitrogen becoming a pollutant. Even though it's a nutrient in our food production system, can become a pollutant if it is in a drinking water source. Sewage becomes the second largest contribution and the fastest growing contributor to reactive nitrogen load. The amount of ammonia, urea, nitrogen that is lost through domestic sewage, if that can be recycled back into, you can cut down the fertilizer by as much as 40%.
Watch Eureka with Professor N. Raghuram, Dean at School of Biotechnology, GGS Indraprasth University, Dwarka, only on Rajya Sabha Television.
Diwali, the festival of lights, is celebrated with great enthusiasm across the country every year. Bursting crackers is the most prominent activity during this festival. But when these firecrackers are burnt, they release gaseous particulate matter and toxic metals that degrades the air quality. In turn, these have severe health impacts like respiratory problems such as asthma, bronchitis, as well as long-term reproductive and developmental disorders. So, before you go out there to burst crackers this Diwali, do pay close attention to our special report.
The Honorable Supreme Court on 9th October put a ban on the sale of fireworks in Delhi NCR till 1st November, saying there was a direct evidence of deterioration of air quality every year during Diwali on account of bursting of crackers. Diwali, the festival of light, has turned into a festival of crackers and pollution. But little do people realize that in our increasingly populated and polluted cities, the temporary joy of watching the fume crackers causes intense air pollution. Fireworks are made of toxic chemicals. Bursting cracker releases sulfur compounds, heavy metal, coal, ozone, sulfur dioxide, nitrogen dioxide, and other chemical elements into the air. Chemicals like barium, aluminium, rubidium, cadmium, mercury and bronze are added to crackers to emit colors and sparks, and inhaling these chemicals cause serious health complications like cough, fever and dyspnea, chronic respiratory and cardiovascular diseases, damaged lung tissue, contributes to cancer and leads to premature death. One Diwali night with extensive use of crackers may cause as much damage to the ecology that a regular pollution does over the span of year. The burning of firecrackers produces gaseous pollutants such as sulfur dioxide and nitrogen dioxide and produce huge amount of ambient particulates into the atmosphere that generates dense cloud of smoke. High concentration of SO2 and NO2 has severe health impacts. It can lead to cardiovascular diseases, respiratory health effects such as asthma and bronchitis, Trapping of pollutants due to burning of firecrackers under cold conditions during Diwali promotes the formation of smog that stays close to the ground for a long time before its dispersion into the atmosphere as seen last year. Smog may worsen the condition of patients with lungs, heart and nervous system diseases. Diwali is also a festival where people have the maximum chances to get burnt. Fire is present in all forms such as diyas, candles and firecrackers. However, with some precautions, accidents can be avoided. Dermatologists advises people to keep a bucket of water and an antibiotic cream handy, as they will prevent the skin from swelling and blisters due to burns. Also, Diwali brings with it a host of firecrackers and their correspondingly loud noises that pets find difficult to bear. The fumes and noises of crackers force the pets to hide under cots and furnitures. Pet owners can take extra precautions to pacify their pets, like distracting them and giving them access to any place they prefer. Taking the pet to a veterinary doctor and giving them anti-anxiety drugs a week or two before Diwali could also help them. Apart from air pollution is another serious problem that we face during Diwali. Noise pollution due to fireworks not only distracts our attention but also causes psychological stress. The most dangerous effect of noise from firecrackers is loss of hearing ability. At 91 decibels, ears can tolerate up to 2 hours of exposure. At 100 decibels, noise-induced hearing loss can occur with 15 minutes of exposure. At 112 decibels, damage can occur with only 1 minute of exposure. At 140 decibels, immediate nerve damage can occur. Excessive noise may cause severe sleep disturbance, fatigue, and irritation due to community noise. According to the World Health Organization, if sound levels exceed 85 decibels, then they could be harmful to human beings. Let us all come together and pledge for a greener, cleaner, and silent Diwali this year.
Marine life is precious, but environmental disasters like oil spills can pose a serious threat to this rich biodiversity. Now, a team of chemical engineers at the Indian Institute of Science Education and Research, IISER Thiruvananthapuram, have come up with a new material to deal with this problem. They have used paper waste and modified it to develop a new low-cost oil-absorbing material. Let's take a look.
Oceans are home to millions of plants and animals. Any damage to its water quality is a potential threat to this marine life. Oil spills are one such polluting disaster that has caused immense loss to oceanic life and economy in the past. Oil spills are caused due to release of oil or petroleum products on the surface of oceans or sea. A major oil spill occurred at the Ennore coast in Chennai in January this year when two cargo ships collided with each other. It polluted the water and damaged the marine ecosystem. The oil covers the sea surface, which blocks exchange of gases, reducing the content of oxygen in water, which adversely affects animals and plants. Now, a team of chemical engineers at the Indian Institute of Science Education and Research, or IISER Thiruvananthapuram, has developed a new material to deal with oil spills. There are some previously known methods to deal with oil spills. For example, burning, skimming, and dispersion. While burning removes oil spill, it causes loss of oil and increases air pollution. The other method, skimming, uses a device to physically remove oil spill. Dispersion is done by using special reagents called emulsifiers, which breaks the oil layer into small droplets. These methods offer minimal help because they are not very efficient. Now, the IISER scientists have made a new material that absorbs oil on water surface very efficiently. 8 grams of this material can absorb nearly 80 milliliters of crude oil in less than 2 hours' time. Scientists tested this material on a variety of oil samples ranging from Bombay High crude oil, Arab Light from Saudi Arabia, Rawa from India, Saharan from Sahara, Marban from Abu Dhabi and Kuwaiti from Kuwait. They found that the new material is very effective on all these oil samples. The new material will also absorb oil when there is turbulence in sea, which is seen during tides. This time, oil spill tends to form an oil in water emulsion. According to scientists, they have tested their material on oil in water emulsions and found that it absorbs oil in these conditions efficiently.
The material we use is very cheap. Cellulose pulp is very cheap. Also, we can get cellulose pulp from recycled papers, recycled newspapers, cardboard, etc. Some governmental agencies like ONGC and Coast Guard have approached us to take it further. So we also, United Nations have contacted us to take it further, to improve, to scale it up and to use in a real life scenario.
The new material looks like small spherical balls. It is made by dipping cellulose pulp into a mixture of 1,2,5,6-diocyclohexylidine mannitol and hexane and then dried. The resulting material has two layers: an inner layer of cellulose pulp and an outer layer that has high affinity for oil. It is highly porous or sponge-like, hence the oil can be recovered from material by applying pressure. Since it is made from cellulose, which can be obtained from waste paper, it is low cost and eco-friendly. The scientists published their results in a recent issue of the chemical Wiley Aggivantic Chemi International, Volume 56, year 2017. The authors have applied for patent with the Indian Patent Office and plan to take this new fascinating oil-absorbing material to global markets. It could prove to be the holy grail for combating oil spill disasters in the country and across the world.
It's time for another breather in here. When we come back, we bring you some more news on science and innovation from India and around the world. But that's after a short break. Keep watching.
Art arisen from a multi-hued cultural canvas. Tradition and cultural fervour dating back centuries. And encircling them all, there's a magic that awes. Embrace your nation's brilliant human warmth. Watch Colours of India, Sundays at 9:30 p.m. on Rajya Sabha television.
Welcome back after the break. Let's now take a quick look at some more scientific innovations and developments from India and around the world.
The third edition of India International Science Festival, or IISF, is being organized by the Ministry of Science and Technology, Ministry of Earth Sciences and Vijayan Bharati or Vibha. The event aims to encourage scientific temper in the country and highlight India's contribution in the field of science and technology over the years. The three-day event is being held in Chennai from 13th to 16th October 2017 at various venues including Anna University, Indian Institute of Technology Madras, Central Leather Research Institute, Structural Engineering Research Centre and National Institute of Ocean Technology. For more information, visit scienceindiafest.org. On the event of book release of science journalist Pallav Bagla and scientist V.V. Benoy's Bridging the Communication Gap in Science and Technology, Lessons from India, Minister for Science and Technology and Earth Sciences, Dr. Harshvardhan emphasized that effective science and technology communication is lacking in India today. The book provides a snapshot of existing communication policy and practice in India across different science and technology sectors and offers solutions in building effective communication. The book is particularly useful for people pursuing the field of science and technology and journalists covering the field of science.
And in the history of science this week, we remember the 11th President of India, the renowned scientist Dr. APJ Abdul Kalam, who was born on 15th of October 1931 in Rameshwaram in Tamil Nadu. Abdul Kalam was a multifaceted individual, an aerospace scientist, author and professor, and served as the President of India from 2002 to 2007. Dr. Kalam contributed to the development of India's civilian space program and military missile developments. He was often referred the Missile Man of India for his development of launch vehicle and ballistic missile technology. He worked on missiles like Agni, Prithvi, Akash, Trishul and Nag. He was the project director of India's first satellite vehicle launch SLV-3. Dr. Kalam played a key technological role during the nuclear test of Pokhran-2 in India in 1998. Dr. Kalam was popular among children for his motivational speeches and was affectionately called the People's President. He received the highest civilian award, Bharat Ratna, in 1997 for his contribution in the field of scientific research, development and modernization of technology in the defense sector. On 27th of July 2015, he passed away while delivering a lecture at the Indian Institute of Management, Shillong. Dr. Kalam is an inspiration for scientists as well as all Indian citizens. And that's all that we could pack for you in this episode. We look forward to your feedback and suggestions. Do send them on our email ID news@vigyanprasar.gov.in. You can also write into us at Vigyan Prasar C24, Kutub Institutional Area, New Delhi 110016. Time to say bye-bye now. We'll see you again next week with all the exciting science news and innovations. Till then, keep watching Rajya Sabha Television.